Okay. We're going to start talking about probability soon, and probability oftentimes requires us to deal with fractions, and so I just want to spend a little bit of time talking about reducing fractions a little bit. So we won't take very long reviewing this concept, but it is an important one for us to keep in mind as we're going through the probability sections here. So just to get us kind of thinking about this, in probability we'll spend a lot of time looking at decks of cards. So this is what a standard deck of cards looks like. You've got for suits, this is diamonds, hearts, spades and spades and clovers, or clubs, and you've got different colors, red and black. You've got numbers ace, which is the same thing as 1, and then 2 through 10, and then jack, queen, and king. These ones over here are called face cards, etc. All of this stuff we'll review when we're going over probability a little bit, but what I wanted to point out was this. If I were to ask you, if you randomly select a card from this deck, what's the probability that the card is black? Then one way that you could answer the question would be to count up the individual cards. There are 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it would be 4 times 13, and that comes out to 52. So there are 52 cards in a standard deck. And then I could count up the black ones. If I wanted to know what's the probability of drawing a black one, I could say, well, out of those 52, how many of them are black? And if you count these up, you should get 26. So there are 26 black cards. And so you could say, all right, so what's the probability of drawing a black card? It would be 26 out of 52. Another way to answer the question, though, would be to simply look at the deck and realize that half of the deck is black. And so the probability of drawing a black card would be 1/2. Okay? And so now the question is, well, which of those is correct? Should the correct answer be 26 out of 52, or should it be 1 out of 2? And the answer is that both answers are correct. 1/2 is reduced. Okay? We like reduced answers better because if you reduce your answer, then the answer is unique. Okay? So instead of everyone coming up with a slightly different answer because nobody's reducing, we can all come up with the same answer if we decide to reduce our answer. And so we need to talk a little bit about reducing. So in a previous background lecture, when we were talking about converting between fractions and decimals, we talked about the fact that 10 hundredths is the same as 1/10. And this picture kind of shows us why that would be the case. Note that if we take 10 1/100ths and divide both the numerator and the denominator by 10, then we would get 1/10. In other words, if we start with 10 1/100ths and we think about what's the largest number that divides into 10 and 100 both, and the answer would be, well, 10, right? 2 also divides into 110, and so does 5, but 10 does, and 10 is the biggest one. So if you divide the numerator and the denominator, if you divide each of those by 10, 10 divided by 10 is 1, 100 divided by 10 is 10. And so that is the way that we reduce fractions. So generally, we can reduce any fraction whose numerator and denominator have a common factor by dividing by that common factor. We like to take out the largest common factor we can, but if you can't think of the largest common factor, that's okay. Just reduce it, and then ask yourself if the reduced fraction can be reduced any further. So I'll give you an example of this with 8/12. I know that 2 goes into both 8 and 12. I also know that 4 goes into both 8 and 12. And I don't think there's a larger number that goes into both 8 and 12. I think 4 is the biggest. So we could reduce this by dividing by 4 in the numerator and denominator. 8 divided by 4 is 2. 12 divided by 4 is 3. So 8/12 turns out to be the same number as 2/3, right? It represents the same quantity. But let's say that you didn't recognize that 4 was the largest thing that goes into both of these. Maybe you just thought it was 2. So then, starting with 8/12, you could say, well, I'm going to divide by 2 in both places. If I do that, 8 divided by 2 is 4. 12 divided by 2 is 6. And now you just ask yourself, can this be reduced any further? Is there a number that goes into both 6 and 4? And the answer is, well, yes, 2, again, goes into both 6 and 4. So I can reduce it by 2 again and get 2/3. And then I can repeat the question again. I can say, is there anything that goes into both 2 and 3? And this time the answer is no. So we get 2/3. Either way you do it is acceptable. You could also use a calculator. Some calculators will reduce fractions for you, and some won't. Mine does. If I type in 8 divided by 12 and hit enter, it automatically reduces it to 2/3 for me. Okay. The Google calculator does not do this. If you type in 8 divided by 12 into the Google calculator, it'll just spit out 0.666666666. It'll just change it to a decimal. So that's the downside, I guess, to the Google calculator. But anyway, worst case scenario, you can always reduce by hand. So I would like for you to try out these 3 problems on your own. I'm going to work them out here in a second, but I want you to pause the video, try them out on your own, and then unpause when you're ready to see the solutions. Okay, so I'm going to go ahead and work out my solutions now. For 10/12, I know that 2 goes into both of those numbers. I can't think of anything larger that would go into both, right? 5 goes into 10, but it doesn't go into 12. 6 goes into 12, but it doesn't go into 10. So I think 2 is the best I can do. So I'm going to go ahead and divide by 2. And that gives me 5/6. Okay. Again, you're welcome to use your calculator. Next one, for number 2, I've got 45 over 60. Goodness gracious. Well, I know that 5 will go into both of these numbers, because anything that ends in either a 0 or a 5 is divisible by 5. So I know that 5 will go into both. I also know that 3 goes into both of these numbers. 3 goes into 45, because 15 times 3 is 45. And 60 divided by 3 is 20. So 3 goes into both of them. So 5 goes in, 3 goes in. So then, since 5 and 3 both go in to 45 and 60, and since those numbers are what we call co-prime, I know that their product is also going to go into 45 and 60. So I know that 15 will go into both 45 and 60. And I think that's the biggest thing that's going to go into both. So I'm going to divide by 15. 45 divided by 15 is 3. 60 divided by 15 is 4. And there you go. Now, I suspect that some of you probably didn't realize that 15 would go in. That's okay, right? We commented on the fact that these are both divisible by 5, so you could start there and say 45 divided by 5 is 9. 60 divided by 5 is 12. Okay? And then you could ask yourself, well, does this reduce any further? And the answer is yes, 3 goes into both of these things. And so you could divide by 3, and then you would get 3/4, just like before. So either way is fine. For the last one, we have 13/17. This thing is not going to reduce. 13 is a prime number. That means that the only things that divide into 13 evenly are 1 and 13. Nothing else is going to go into 13 evenly. Same thing with 17. 17 is also prime. So when you have a prime number divided by a prime number, you can be certain that that thing's not going to reduce any further. So this one is sort of a trick question, right? It's already reduced. Okay. And that's that, right? That's all I want to say about reducing fractions. If you need some more practice, you can get onto like Khan Academy and search for, reducing fractions. Khan Academy is spelled Khan. So here, let's go Khan Academy. They have all kinds of free stuff. So there it is, Khan Academy. So if you do a Google search for Khan Academy, you get all kinds of stuff here, and you can search for like reducing fractions or something, and I'm sure something will come up. See, reducing fractions. So simplifying fractions, right, or equivalent fractions. So stuff like this would be good. So you could do Khan Academy, or you could go to the Math Lab and get some help there. But that's all I'm going to say about reducing fractions for now. Other than, let me just say, I guess, one last thing, and that is that when you give your answer as a fraction on a test or a quiz, it needs to be reduced. If you don't reduce your fractions, I'll probably mark you down. Okay, but that's that. So get some extra help if you need it. Otherwise, that's all we'll need to know about reducing fractions. We'll have some more stuff with fractions a little bit later on.